Okay, good morning to everyone. This experiment is about undamped free vibration of a spring mass system. This is a practical which is based on unit number 3. So here we are going to find out the frequency of the vibration of this spring and mass system. We are going to add up the weights over here and we will allow them for oscillations, and then we will find out the frequency of the vibration. So we will be taking out 3 trials based on for different weights added. So first we are going to start with 3 kilogram. Before that, we have to find out the initial displacement value. Here in this wooden scale, you can see the mark as 42.5 from the bottom. Okay, I am taking it as a 0 reference. So and then I am adding up 3 kilograms of weight for better oscillations. So after adding 3 kilograms, you can see the deflection which is around 40.7, that is around 17 mm. The difference is going to be 17 mm, which I am taking it down as 17 mm in the tableau column. And then we are going to oscillate it for 5 oscillations. We can take in 10 oscillations also, it depends. So I am going for 5 oscillations. It has taken around 1.94 seconds, that is 2 seconds for 5 oscillations. So the T theoretical is equal to number of time for 5 oscillations divided by 5, which will give you the value for T experimental, which has to be taken out over here. Okay, so 2 divided by 5 is going to be 0.4 seconds. So T experimental is 0.4 seconds. So for the next trial, we are going to add 1 more kilogram, which is 4 kilogram, and then we have to see the deflection. So at initial it was 42.5, now the deflection is 38.5. So it is around 40 mm, 4 centimeter. Okay, and we are going to repeat the trial for 5 oscillations. So it has taken 2.5 seconds for 5 oscillations. So repeating the same procedure, we have to 2.5 seconds for 5 oscillations, and then we are going to add 1 more weight, which is 5 kilogram. Now you have to note down the deflection, which is around 36.5. So 42.5 minus 36.5, which will give you 6 centimeter, which is 60 mm. So now we are going to go for time trial. So it has taken 3.909 seconds. So 3.09 seconds divided by 5 will give you the time experimental value. Okay, we'll go with the calculation now for the first trial. So for the 3 kilogram, it is taken as 17 mm deflection. And the time taken experimental for 3 kilogram is 0.4 seconds. So this is what we have taken from the experiment. So going for the calculation for the first reading, stiffness K is equal to mg divided by rho, which will give you the answer 1731.16 Newton meter. So 10 power minus 3 is because of mm is converted into meter. Next, T theoretical is equal to 2 pi root of m by k, which will give you 0.261 seconds theoretical, which is noted down here. Next, for F theoretical, 1 divided by T theoretical, which is equal to 3.82 Hertz. So which will give you the answer of frequency of theoretical value. So going for experimental, whichever we have taken from the time. So for 0.4 Hertz, 0.4 seconds, calculating the experimental value is going to be 2.5 Hertz. So similarly, you have to do the calculations for the 4 kilogram and 5 kilogram. Thank you.